So, identify asymptotes. You said both vertical and horizontal. So, how do I find vertical asymptote in general? It's the same way no matter what. So the bottom equal to 0 and solve, right? So for the first one, I'm going to take the bottom, set it equal to 0. So x plus 2 equals 0. And I solve, how do I solve that? Correct 2. So it's going to be at x equals negative 2. That's my vertical asymptote. Over here, my vertical asymptote. Okay. Thing, set the bottom equal to 0. And solve. Like what? 3. So x equals 3. Okay, so vertical asymptote's the same, no matter which of those forms you get. It's going to be the same today, too, when you do a little more challenging ones, too. Vertical asymptote's always when the denominator equals 0. Okay? Now, horizontal asymptote changes a little bit. Okay, horizontal asymptote. It depends upon which form it's in. So you got to recognize which one it's in. So if I have an x on top and bottom, okay, this is the one that's going to change. If you just have an x on bottom, what you do is you look out here. What's being added or subtracted on the end. Okay, so in this case, the horizontal asymptote is at y equals what? Negative 5 at k. Here there is no k because it's not in that form. X equals negative 5 is the horizontal asymptote. Here, does anybody remember how to find it if you have x's on top and bottom? Divide what? Kind of, we generally don't use the x's. Okay, if the powers are the same, these both have 1s on them, right? The powers are the same, you do the ratio of the leading coefficients. So the leading coefficient divided by the leading coefficient. So what's the leading coefficient on top? 4. What's the leading coefficient on bottom? 1. There's nothing out there, so it's really a 1, right? So the horizontal asymptote is at, what's 4 over 1? 4 over 1 is just 4. Okay? So depending upon what form it's in, today we're going to add a third option. Okay? About asymptotes. Alright, so that's how you find vertical. Vertical is the same no matter what. Denominator set it equal to 0. Horizontal asymptote, you got to know which form it's in. Okay, if it's in the standard form, okay, of the reciprocal function or the inverse function, then you can just look at k. If it's not, if it's in px over qx, then you have to use the rules. If they're the same degree, you do leading coefficient over leading coefficient. Okay? All right. All right. So today we're going to graph more complicated rational functions. So everything's pretty much the same. The only thing we're going to do is add one piece. We're going to find x-intercepts. Okay? So x-intercepts occur when y equals 0. Okay, now they say set p of x equal to 0. Well, in this case, p of x is the what? Where's p of x at? P of x is in the numerator. Well, the reason why we do that is because when I plug in 0 for y, or f of x in this case, the only time a fraction can equal 0 is when the what? And what's 0? Top. The numerator has to be 0. Yeah, if the denominator is 0, it's not equal to 0, it's undefined. So the only time a fraction can equal 0 is when the top equals 0. The numerator equals 0. Okay, so that's what you're going to do. To find the y or the x-intercepts, you set the top equal to 0, the numerator equal to 0, and solve. Okay? The vertical asymptotes, or the discontinuities, are when the bottom equals 0, just like before. Set the bottom equal to 0 and solve. So x-intercepts, you set the top equal to 0. Y or vertical asymptote or discontinuities, like I said, take pre-calc next year, it's not going to be just a vertical asymptote. You set the bottom equal to 0 and solve. Horizontal asymptotes. Okay, so it depends upon the degrees of the top and the bottom. So, what I always say is, it's y equals 0 if the bottom is bigger than the top. The degrees. Talking about the degrees here. If the degree on bottom is bigger than the degree on top, it's at y equals 0. Okay? If the degrees are equal, that's when you do the leading coefficient divided by the leading coefficient. The degree on bottom is equal to the degree on top. Then it's going to be, like I said, you do the leading coefficient divided by the leading coefficient. We talked about yesterday. That's what this is saying. This is using the notation up top. Okay? C. If the top is bigger than the bottom. If the top is bigger than the bottom, the degree, talking about the degree. We know what the degree is, right? How do I find the degree of something? The highest power. The degree is the highest power. So if the degree on top is greater than the degree on bottom or bigger, there is no horizontal asymptote. Okay? So we talked about this one we did the other day when we just did 1 over x minus whatever, minus h plus k, when we did that. Okay, the degree, we put a constant on the top. Okay, we also did these yesterday when we had like 3x plus 2 over 5x minus 6. And that meant the degrees were the same. Now we're adding the caveat where if the degree on top is bigger, there is no horizontal asymptote. Okay? Alright, this one we should know how to do. This should be a review of yesterday's. This shouldn't be too hard. Okay, so with your group right now, try this one. This is a review of yesterday. There's no difference. The only thing we're adding, actually I'll do the x-intercepts with you real quick, and then you can do the rest. Alright, so the x-intercepts. When do x-intercepts occur? What do we do? Find the x-intercepts, we got to do what?
Set it to 0.
So what equals 0?
Bottom.
Oh.
Oh,
Top
x-intercepts,
equals 0.
sorry.
X-intercepts. Top equals 0, yeah. So the top is what? 5. So when does 5 equal 0? Never. So what does that mean?
There's no x.
There's none. This never touches the x-axis. Never crosses the x-axis. Okay? So now go ahead and do the rest of it. Find the vertical asymptote. Find the horizontal asymptote. Okay. Sketch the graph. Work with your group. Talk to each other. Help each other. So let's review what we did yesterday. So did we find the vertical asymptote? Where's our vertical asymptote at? 1. Okay. Where's the horizontal asymptote at? Careful. Not 5 because there's no x there. The degree on top is 0, the degree on bottom is 1. So the bottom's bigger, so it's at y equals 0. So I got those. Now I go to my table. To do my table, I do what? I take the vertical asymptote, plug it in the middle, pick a couple points on each side. So 0, -1, 2, 3. Okay, now this one's not too bad to plug them in. If I plug in 0 up here, it'd be 5 over 0 minus 1, which would be -1. 5 over -1 is -5. Plug in -1. -1 minus 1 is -2, so 5 divided by -2 is -2.5. What's that?
Yeah, why is it
The horizontal asymptote is at 0 because the degree on top is 0, the degree on bottom is 1, right? So the degree on bottom is bigger, so it's that way. Or this is the case where there's no x on top, so I can look out here. And out there, what am I adding? What's k? K0. Okay. Plug in 2, so 5 over 2 minus 1 is 1, so 5 over 1 is 5. Plug in 3, 3 minus 1 is 2, so 5 over 2 is 2.5. Alright, so 0 is at -5. -1 is at -2.5. So now, how do I sketch this? This is going to what? Yep. Follow those two asymptotes. It's a simple one. Okay, so it's going to go like that. 2 is up at 5. 3 is at 2.5. Same thing. It follows like that. Okay? Now, it didn't ask us, but what would the domain and range be? What do I do to find my domain? Domain is going to be everything but the vertical asymptote. From -infinity to 1 in union with 1 to infinity. Okay, now my range goes down to -infinity, comes up and gets really close to, but never touches 0. And then on this side, it gets really close to 0, and then goes up to infinity. But it never actually gets to 0 on either side. So it's going to be from -infinity, so I have to put a break in at 0. So I do my inner range. Alright, that's kind of similar to one we did yesterday. Now the next one. The next one has x squared on both top and bottom. Okay? So to find the x-intercepts, find the vertical asymptotes, find the horizontal asymptotes. Graph. Alright, so how do I find the x-intercepts?
You got it. Set the top 0.
Top equals 0, yeah? So when I set the top equal to 0, we need to remember back to chapter 2, how to solve this, or 3, whatever it was, 4. How do we solve this? We're doing x-intercepts right now. So I'm trying to solve 4x squared minus 1 equals 0.
5, 4. Add 1.
Add 1 first. There's only one. The reason I can do that is x squared, but there's only one x term. So I can undo everything that's being done to it. So I'll add 1. So the x squared equals positive 1. Then what?
5.
Divide by 4. So x squared equals 4. Now what? Square roots. I'm doing a square, I take a square root. What do you got to remember to do? Oh, sorry, this should be 1 4 times. What do I got to remember to do when I take a square root?
You gotta do both sides.
Got to do square root both sides? Yep. What else do I got to remember?
Oh, plus or minus.
We do plus or minus. So it's plus or minus the square root of 1/4. So I'm going to have two answers. I'm going to have positive square root of 1/4. So what is the square root of 1/4? Well, do the square root of the top. What's the square root of 1?
Actually, it's
Square root of 1 is what?
1.
1. What's the square root of 4? 2. So 1/4 squared would be 1/16. Okay. Then I also have what? 1/2 and negative 1/2. I got both those. Okay? Now, what is my vertical asymptote? How do I find the vertical asymptote? Bottom equals 0, right? So it's 8x squared minus 8 equals 0. So how do I solve that? It's x squared, but there's only one x term, so I can undo. So I add 8 to both sides, so I get x squared equals 8. And what? Divide by 8. So the x squared, 8 divided by 8 would be 1. Now what do I got to do? If I undo the square, take the square root. You've got to have 2 vertical asymptotes. So it's going to be what? Plus or minus, what's the square root of 1? 1. So it's positive 1 and negative 1. I said they were going to get a little trickier today. So negative 1, positive 1. Okay? You know, we have x-intercepts at 1/2 and negative 1/2. So here and here. Those on there. Now let's find our horizontal asymptote. So we got to look at the degrees. What are my degrees? What's the degree on top?
2.
2. What's the degree on bottom?
2.
So if the degrees are the same, you do what?
Divide the leading coefficient.
Divide the leading coefficients. So it's going to be y equals, what's the leading coefficient on top?
4.
4. What's the leading coefficient on bottom? 8. So it's 4 over 8.
1.5.
5 over 1/2. So I have a horizontal asymptote at 1/2. Alright, now we're going to use our calculator. So now, before we talk about this, how am I going to enter this into my calculator? Where do I go to enter it?
Yeah.
Go to group, well,
Y.
y equals, right? So in y equals, in y1, I'll plug in this. You have to use parentheses first. So you do parentheses, 4x squared minus 1, and the parentheses divided by parentheses. The whole bottom's got to be in parentheses also. 8x squared minus 8 and the parentheses. That's how we're going to plug that into our calculator. Okay, so the values we had said, I used the calculator to make my table on this one. The table of values. This way, I got my room that way. So I'm going to put -1 and 1 on there. Those are undefined, right? Okay, 0's in the middle. -2, +2, 3, -3. Okay, so this one's going to be 0.546. This is going to be 0.625. 0's at 0.125. 2 is at 0.625. 3 is at 0.546 or 7-ish. So let's plot all those. -3 is at 0.54, so just above. This is at 0.5, so it's just above the asymptote. Okay, then at -2, I'm at 0.6, so it's not much further up. Okay, they didn't give you a very big graph on this, so now we already graphed it, so we know it should do this on my calculator. Does that? The next piece of this. So I'm at 0.125 at 0. It's there. So I should know that this does this. Goes up. Goes back down. Like that. The next one at 2, I'm at 0.625. And 0.54, so it's really close to that horizontal asymptote there. Do that. Okay? Now, this one, they didn't say to do domain and range. The domain would be everything but 1 and -1. So it'd be -infinity to -1. Here's how you'd write it. We're going to exclude those. There's 2 of them now. So I go from -infinity to -1. Okay, then it breaks at -1. And between -1 and 1 it exists. Okay, and then it breaks again at 1 and goes to infinity. So that would be your domain. That's how you write your domain. Just put all the vertical asymptotes in there as your breaks. -1 and 1. Okay, so I have a break at -1, I have a break at 1. Okay? Now, range is a little trickier on this one. Okay, because normally we just use the horizontal asymptote. But this one, there's a gap. Okay, because the 2 left and the right sides, the far left and far right, are both above. These both go from just above 1/2 up to infinity. But in here, there's actually a maximum. So what you have to do is there's a small little gap between this maximum and 1/2. Okay, so you're going to have to find the maximum there if you want to do it. Didn't ask you to do it. Okay, there's a little gap in there, so you'd have to find the maximum there on the calculator. And so you go from -infinity up to whatever that max is, and then from 1/2 up to infinity. Okay? So, do you remember how to find a max? Do it. No, it's actually, well, actually, then looking at 0 again. But don't assume it is. So yeah, we verified on the calculator that that 0 was the max. So my range then would be from -infinity up to that maximum. Now, does it actually get to that maximum value? Yeah, that's where it goes and stops and comes back, right? So for this one, we need a bracket because it's a maximum. It actually goes to that and then turns around and comes back. Now, the 1/2, then it goes above. The rest of the graph is from 1/2 up to infinity. But does this ever get to 1/2? That's the asymptote, so it never gets there. So it's just, you put a parenthesis there. Okay? You don't have to do one of those on the test for something that complicated. What if you take pre-calc next year? That's if you do these. Okay? Alright, next one. The next one's a little bit easier. If you remember how to solve a quadratic. This one's not a bad quadratic. Alright, so to find the x-intercepts, what do? Top equal to 0, right? It's going to be x squared plus 5x minus 6 equals 0. Really what you're doing to find the x-intercepts, you plug in 0 for y. Okay? But one time a fraction can equal 0 is when the top equals 0. That's why we do that. So do you remember how to solve this? No, you got to factor. So it's a quadratic. You can't like add 6 or anything because we have two different x terms. So we can use the shortcut. We can say what multiplies, so we got x and x here. What multiplies to negative 6 and adds to positive 5. So what's that? So that multiplies to negative 6?
Negative 5.
Multiplies to negative 6 and adds to 5.
Negative 1 and 6.
Negative 1 and positive 6. It's got to multiply to a negative, so I need one negative, one positive. It's going to be negative 1 and positive 6. Yep. Send it backwards.
Yeah.
So, how do I solve those then? How do I solve it? Once you have it factored, use zero product property. If A times B equals 0, then either AS equals 0 or BS equals 0. Well, how do I solve x minus 1 equals 0? And 1, so x equals 1. How do I solve x plus 6 equals 0? Subtract 6, so it's negative 6. And the zeros are the x-intercepts, are where it crosses the x-axis. Positive 1 and negative 6. I know that. Now I need to see my vertical asymptotes. So vertical asymptote is when what? Bottom equals 0, right? So when does x plus 2 equal 0? When x is negative 2. So the vertical asymptote by negative 2. Horizontal asymptote. So you gotta look at the degree and the on top and the degree on bottom. So what's the degree on top? 2. That's power. What's the degree on bottom? 1. So when the degree on top is greater than the degree on bottom, what does that mean?
It's nothing.
There is no horizontal asymptote. None. Okay, that's the rule. You got to know those rules. Okay, so there is no horizontal asymptote. Alright? So now we're going to use the calculator to look at the graph and get my table. So to graph it, make sure you use the whole top in parentheses divided by the whole bottom in parentheses. So let's see, from the table on the calculator, we got negative 8 is at negative 3. So x is negative 8. Right down to negative 3. We know it goes through 0 there. Negative 5 is at 2. Negative 4 is at 5. Negative 1 is at... Oh, negative 1's on the other side, it jumps. So it's going to do this. It does this. Okay, and then at negative 1, I'm at negative 10. At 0, I'm at negative 3. Okay, at 1, I'm at 0. At 2, I'm up at 2. 4, I'm up at 5. So it's going to go like this. So there's my graph. Alright? So we added the x-intercept piece at the top equal to 0. We added the none piece for the horizontal asymptote. And the degree on top is bigger than the degree on bottom. Okay? A lot of the rest of it's the same though. Yes, sir.